All right, today we're going to be talking about special right triangles. So we're going to start with the 45, 45, 90 triangle. And I drew three triangles here. And the reason why I drew three triangles is because I want to point out to you that sometimes they'll tell you it's a 45, 45, 90. Now we're assuming that you know this is 45 because they all have to add up to 180. But sometimes they just do this to you. Well, because those two sides are congruent, their opposite angles are congruent, so they must both be 45 if it's going to add up to 180. Or they'll do this to you. So if these are congruent, they must both be 45. So I just wanted to kind of show you that if you see this kind of triangle, it is a 45, 45, 90 triangle. When I talk about these, since we know these two sides are the same, you can call this your side and your side. What's special about these triangles is they follow a pattern. So if it's a 45, 45, 90 triangle, the sides are the same, but then your hypotenuse is the side length times the square root of 2. Now another way that some teachers talk about this is they call this x, they call this x, and they call this x square root 2. Okay, so you might see that different ways, but they both mean the exact same thing. Sorry about the bell in the background there. Let's look at the 30, 60, 90. So on the 30, 60, 90, since this is 30 and that's 60, remember when you were in geometry and you learned that the largest side is across from the largest angle. So the hypotenuse is your largest side. So that must mean that across from your 30 is your shortest side, right? So I tend to call this my short side, okay? So that's my short side. This is my hypotenuse. And I just call this my medium side, okay? So everything is going to be based off of the short side. So whatever the short side is, if you take that number and you multiply it by root 3, you'll have your medium length side. And if you take that short side and you multiply it by 2, you'll have your hypotenuse. Now another way that you may see this written is they'll call this x, and then they'll say, okay, well if that's x, then my medium side must be x times root 3. And my hypotenuse then must be 2 times x. So it depends on what teachers you have or you've had in your past on how that is shown to you. Okay, so let's use this information down here on number 1. On number 1, we have a 30, 60, 90. And the first thing I like to do is I like to label my sides. So across from the 30 is my short side. And across from my 60 is my medium side. And across from my 90 is my hypotenuse. Now we know the short side here, so that's awesome. We can use this triangle to figure everything out. So the medium side then would just be the short side times root 3. So if this is short side times root 3, and my medium side is y, if the medium side is short side times root 3, then that must mean y equals 1/2 times root 3. And that's your answer for that one. Okay? So let's work on hypotenuse. It's 2 times the short side. So if the hypotenuse is 2 times your short side, your hypotenuse is x, and that's 2 times 1/2. Well, half of 2 is 1, so x equals 1. Now over time, hopefully you won't need to use these. You can just see the pattern and just go right to it. But for now, I'll use the equations to help you out. Let's look at number 2. On number 2, I label my sides first. This is my short side. Across from my 60 is my medium side. And across from my 90 is my hypotenuse. Now, all that I know here is my hypotenuse. And I know that the hypotenuse is the short side times 2. So my hypotenuse here is 18 root 7. So 18 root 7 equals 2 times my short side. Well, how would I get short side alone here? Divide both sides by 2. So then we'll have 9 root 7 equals my short side. So let's find the short side. Here it is, it's x. So x equals 9 root 7. Okay, so we still need to solve for y. Y is our medium side, which is the short side times root 3. Well, I know that my medium side is y. They've named it y. And my short side I found is 9 root 7. So 9 root 7. Bring down the root 3. I like to call the root 7 and root 3 innies because they're both inside the radical. So we'll have 9 root 21. And if you break up 21 with a factor tree, nothing's going to come out. So it's just going to be 9 root 21. Okay? So I'm going to go ahead and move on to number 3. On number 3, we're going to label it again. So there's short side, here's your hypotenuse, and then here's your medium side. So let's work on this one. I know my medium side, and I know my medium side is the short side times root 3. So my medium side here is root 3 over 2. So root 3 over 2 equals the short side times root 3. Now you want to divide both sides by root 3, but you also should know that dividing is the same as multiplying by the reciprocal, right? So multiply by the reciprocal here, multiply by the reciprocal here. These cancel out. And here, these cancel out. Isn't that awesome? Like how they just go away like that? And what's left over is a 1 on top and a 2 on the bottom. So that means my short side is 1/2. So find the short side here, and it's right here. So x is 1/2. Now we know the hypotenuse is the short side times 2. What was my short side? It was half. So my hypotenuse then is 1/2 times 2, and half of 2, oops, we need to write y there. Half of 2 is 1. So my y equals 1 right here. Okay, let's keep going. Let's focus now on some 45, 45, 90. So notice that this is a 45, 45, 90 because both sides are the same. And here they've told you the 45s. Let's look at number 4 first. So when I label these, this will be side, side, and then this is the hypotenuse. And the hypotenuse is always the side times root 2, like that. What were we given here? Well, we were given that the side is 8 root 6. So this is going to be the same, 8 root 6. And then our hypotenuse, which is y, is the side, which is 8 root 6 times root 2. Our innies are 6 and 2. So y equals 8 root 12. But watch out. When you take the 12 and you break it up, this is 4 times 3, and that's 2 times 2. What do we have a pair of there? A pair of 2s. So that's going to come out. So 8 times 2, and the poor little 3 is going to stay inside. So y equals 16 root 3 for this one. Okay, just using the formulas. So let's look at number 5. On number 5, I've got side, side, and then my hypotenuse here, and we know the hypotenuse is the side times root 2. Like that. Well, we know the hypotenuse here. It's 6 root 5. So 6 root 5 equals the side times root 2. To get the side alone, we have to divide both sides by root 2. So 6 root 5 over root 2. However, you're not allowed to have a radical in your denominator. So in order to get rid of it, we're going to have to multiply the top and bottom by a root 2. It's called rationalizing your denominator. So we'll have 6 root 10 over root 4. And then what's the square root of 4? Square root of 4 is 2. So 6 root 10 over 2. And then 6 over 2, those are outies. They're outside the radical. We can divide those, and we get 3 root 10 equals our side. Oh my gosh, that was a lot of work, but that's probably as long as they get, just to let you know. So if our side is 3 root 10, so this is 3 root 10, and over here, my y is 3 root 10 also. What I'm going to ask you to do is go ahead and try number 6 and bring that to class. Go ahead and try that one out. It's very similar to what we've been doing, and hopefully you'll be able to get that one correct, and we'll go over it in class. So let's keep moving on to this next part here. We're going to use the special rights with the coordinate plane as reference angles. So instead of using x here, I just used 1s, and this is the same thing. 1, 1, 1 root 2. 1, 1 root 3, 2 times 1 is 2. Okay, so it's the exact same thing except I said that the length was 1. It's just another way of looking at the special right triangles and seeing the pattern. So let's look at number 7. Okay, on number 7 here, first let's find out where 315 degrees is going to be. And I want you to use a length of 1 for all of these. And you'll see what I'm saying in just a moment. That's 180, that's 270. So 315 must be somewhere over here, correct? 315 must be somewhere over here. And then let's connect this to our x-axis. Well, how many degrees is here? 315, and that's supposed to be 360. 360 minus 315 will give us 45 degrees. Now I said to use a length of 1 here. And if this is a 45, 45, 90 triangle, then we know these two sides will be the same. However, this one right here, is that one going downward or upward? Is it going in the positive or the negative direction? And it's going in the negative direction, so you want to put a negative on that right there. And then we know that this right here would be root 2. So all I've done is I've transferred this over to here. So now we have to find the sine of 315. Well, let's talk about SOHCAHTOA. So sine is opposite over hypotenuse. If 45 is your angle, your opposite here, your adjacent is here, and your hypotenuse is here. So the sine of 315 then will be opposite, which is -1, over hypotenuse, which is the square root of 2. But you know you can't leave that, right? Because you have to rationalize the denominator. So we'll multiply the top and bottom by root 2. So sine of 315 equals -root 2 over, what's the square root of 4? 2. And you have sine of 315. Let's talk about number 8. Solve for the tangent of pi over 6. This is actually a problem that I don't really want to get into just yet. I would rather wait till we get to unit circle stuff. So we're going to just cross off number 8 for now. Okay, so just cross that one off. So let's keep moving downward here. So I think I'll leave 9, but let's talk about 10 a little bit. So solve for the cotangent of pi over 3. So pi over 3, if you did that, would be right about here, right? Because it's in the first quadrant. And pi over 3, what is it as? A degree. So that would be pi here over 180. If you cancel, we end up getting that at 60 degrees. So if this is 60 degrees, then this is your medium side, and this is your short side, and this is your hypotenuse. And remember I said to use your short side as 1 for now. So my short side is 1. What's my medium side then? Remember what we have up here? Here's your medium side, short side, hypotenuse. So your short side's 1, your medium side is 1 root 3, and your hypotenuse is just going to be 2. So let's talk about cotangent. So if we know we have SOHCAHTOA, where does cotangent come into play? Right here. Cotangent is going to be the flip of opposite over adjacent. So it's going to be adjacent over opposite. Well, if we label that in our picture here from the 60, here's our opposite, here is our hypotenuse, and here's our adjacent. So the cotangent of pi over 3 then, because that's what that is going to be adjacent, which is 1, over the opposite, which is root 3. But you are not allowed to leave that. You have to rationalize. So if I multiply the top and bottom by root 3, I get that the cotangent of pi over 3 is equal to root 3 over, what's the square root of 9? 3. Okay? What I would like you guys to do is try number 9 on your own. Now that you've seen cotangent there, go ahead and try that one on your own. And then we'll also talk about number 11 in class 2. All right, see you in class. Make sure you do those problems and come with questions. See you then.